What if there was a way to heat and cool our buildings that works with our natural Earth systems in a symbiotic relationship? Good news, there is a way. This time I'm here to show you how we are doing just that with geothermal energy at Agnes Scott. If you remember the credit categories of LEED certification that I talked about last time, there are some really important points we can earn for our energy and atmosphere credits through utilizing geothermal energy. Here at Agnes, we are lucky to have a team that is working hard on Rebekah, but the same can be said for Campbell Hall. For folks who aren't aware, Campbell Hall is using a geothermal energy heating, ventilation, and air conditioning system, also known as HVAC, as well. And without the work put into making that happen, we wouldn't be where we are with Rebekah. So let's get started on this explanation. When we look at the word geothermal, we see geo and thermal. These come from the Greek words geo, meaning earth, and therm, meaning heat. Beneath the crust of the earth, there is a zone that maintains a continuous temperature no matter what time of the year or what season it is. Depending on your altitude, that depth changes. For us, it is 150 feet to 500 feet deep. The temperature ranges from 64 to 68 degrees Fahrenheit. Geothermal HVAC systems take advantage of the Earth's temperature. It's important to note that this system isn't creating the heat, it's just moving it. A crucial part of using geothermal energy is understanding what geothermal HVACs are and how they work. The geothermal HVAC system includes three parts. The first is the closed ground loop. So how do we get down into the earth anyways? Drilling! There will be 42 wells for Rebekah Hall, and over half of them are already drilled. Around 100 feet down, you hit solid granite. 500 feet can be hard to visualize. So imagine you're standing at the Washington Monument looking up at it from the ground. That's really deep. Great, we have a bunch of holes in the ground, now what? Pipes, of course. Because this is a closed-looped system, the pipes are all connected to each other. Moving through the pipes is refrigerant. This liquid is our heat exchanger. It is constantly moving through the pipes that are in the wells in a cycle. How does this refrigerant exchange heat? As explained by the United States Department of Energy, the Earth is used as a heat sink in the summer and as a heat source in the winter when it comes to geothermal. So imagine that it is summertime in Georgia. The outside temperatures are 80 degrees plus, while the Earth's temperature is relatively 20 degrees cooler. As the refrigerant moves down the pipes through each loop, it exchanges the heat to the Earth. With each added well, the refrigerant becomes cooler, which is why we have 42 wells. In the winter, the Earth gives its heat to the refrigerant as it passes through the wells, therefore warming it up. Next is the heat pump, which is located above ground. This is where the refrigerant makes its final stop in the closed-loop system to exchange heat with the air systems before returning back to the Earth. Basically, the heat is always moving where it currently isn't, and any residual heat is then used for hot water heating. The last part is the air delivery system. Once the air has been compressed and sent to the evaporator, it goes through this system which delivers air to your room through air ducts in the form of either AC or heat. So now that you understand geothermal energy, why are we using it here at Agnes Scott? According to the EPA, geothermal HVAC is the most highly efficient method in the world. Agnes Scott was able to bring Campbell 51,000 square feet onto the grid without seeing a substantial increase in our campus's electricity usage and with no use of natural gas in the building for heating. We also estimate that we save about 500,000 gallons of water a year by not using conventional air conditioning. This is even more important because Rebekah didn't have air conditioning on the upper floors before the renovation started. This also means we did not impact the college's carbon footprint with the air conditioning and heat for the building. Using geothermal energy for Rebekah is an essential step toward reaching our goal of climate neutrality by 2037. Thanks for staying in the closed loop. Tune in at the beginning of November for the next video.